right, hello everybody and welcome to this new Open Class 136. Welcome back. We've taken a quite long break from the last one, but we are back again with the Open Classes on Tuesday, 18 p.m. CET. So hello everybody and welcome to this new Open Class. Today we are going to be talking about ROS2. Well, not talking, but actually practicing and working with ROS2. Specifically, we are going to be checking managed nodes. So what are managed nodes in ROS2? This is a very interesting topic in ROS2. So today we are going to be learning what are these managed nodes and how to create one, how they work inside, and as always, as we like to do, with practice. So you are going to be practicing there at the same time as I am going to be doing it. So hello everybody, and let's not lose any more time. First of all, I would like to know if everything is all right. I'm going to switch right now to my computer screen so that you can see what I am doing here. So let me come very quickly here to the workshops. So I should be live right now here. Here I am. Okay, I can see here Marco, David, Zoltan, Jürgen, Abhishek, Nawami. Nawami is asking, does anybody know if this will be recorded? Yes, Nawami, this is being recorded, and after this open class finishes, it's going to be uploaded to our YouTube channel. All right, so in case you want to review it later, you don't have time now or you have other things to do, this is going to be uploaded to YouTube, so you are going to be able to review it there. All right, hello from South Africa, says Logan. Hello, Logan. All right, so everything seems to be working okay. Can you confirm there in the chat if everything is all right? Can you hear me properly? Sound is good? Image is good? Yes? No? Let's see. Yes, says Zoltan. All right, then let's keep going. So let me remind you that the first thing that you have to do in order to be able to properly follow this open class is to get the ROSject related to this open class. And how can you do this? Very easy. You have to click on this light blue button that we have right here above the chat, which says fork and open the class ROSject. Okay, just click here, and this is going to automatically copy into your workspace and open automatically, as you can see, the ROSject. Okay, so what is a ROSject? Well, a ROSject is a project which is based in ROS, of course, which contains many different developer tools like an IDE, Linux terminals, etc. And it also contains a notebook, which is going to be opened automatically, as you can see right here. This is the notebook related to this ROSject. And you are going to be able to follow also the class here. You have it here attached at the right side of the screen. In case you want to, you can move it to a different tab. In case you don't want to have it here taking space, you can click here and it's going to be moved to a different tab, etc. All right. I'm going to leave it open here for now because I want to see your comments in case you have questions, whatever. I want to have the chat open here so that I am aware of what all of you are saying. All right. So, so then all of you should do this. Okay, I'm going to show it one more time. So here from the workshops page, okay, you have the current live class going on right here. Then you have to click on this light blue button, which is above the chat, which says fork and open the class ROSject. Okay, this is going to automatically copy this ROSject into your workspace, into your account. So you are going to have this ROSject in your account forever, in case that you want to review it later or tomorrow or another week. You are going to have already this ROSject copied into your workspace. And then this is going to automatically copy it and open it. All right, so you should be in this screen right now. So let me know, guys, are you all here with the ROSject opened, the notebook ready here to follow? Everything is properly set up. Are you on the same page? I want to make sure that all of you are here so that we can start at the same point. Because, as always, I want you to be practicing, all right? So I'm going to be doing, I'm going to be explaining some things, but I'm going also to be doing some practice, creating code, etc. And I want you to be doing so also with me, all right? So I don't want you to be just sitting there and listening and watching to what I am doing, but I want you to be practicing also, okay? This is very important. Ryan says, project open, notebook visible. Okay, excellent, Ryan. Thanks for the feedback. So let me get some energy here. And let's go for it. All right, so yeah, today is open class number 136. And as I have said in the intro, we are going to be talking about ROS2 managed nodes, okay? Then the first thing we are going to do is to set up and launch a simulation, in this case, a ROS2 simulation. All right? So for this, we are going to open a new shell. All right? In order to open a shell, we have to click in this icon that we have here in the bottom bar. The first one, which says web shell. So I'm going to click here, and this is going to open a new shell. This is just like a regular Linux Unix terminal, okay, so you can type any commands here. And then in this case we are going to type these ones, okay? You can copy these commands directly here from the notebook. In fact, I'm going to do so. So you can, in order to speed up the process, you can copy directly the commands from here and run them in the shell. In this case, the first one is to source this simulation to workspace, and the second command, this one, ROS2 launch, is to actually start the simulation. So I'm going to run this command here, and this is going to start printing here the output. This is starting all the systems, starting the gazebo simulator, and so on. And then after some seconds, you will see that the gazebo window automatically pops up here, and this is going to show us the simulation. All right, here we have GZ client opened. And we can zoom in a little bit. We are going to see this very simple box-shaped robot, okay, with a couple of wheels. It also has a laser, as we are going to see in a moment, okay. But basically, you are going to get this robot in Gazebo loaded. It's working under ROS2, okay. So this robot works on ROS2. So all of you guys should see this gazebo simulation with this very little box-shaped robot, two-wheeled robot. So can you confirm? So far, so good. Have you been able to start the simulation? Any issues so far? David is giving us the thumbs up. Sorry. Okay, so apparently everything is going all right. So yeah, let's keep moving. Okay, so, okay, Ryan also gives us his thumbs up. Great. I'm going to give mine also. All right, so yeah, let's keep moving. Then, yeah, once we have the simulation, we are ready to start the actual work, okay? Then, managed nodes. So what is a managed node? First of all, let's get some context, and let's try to get a first idea of what a managed node is. So in ROS2, nodes can be of two types. One is the regular node. Yeah, so very often you are going to be using this one. This is the regular node, similar to a ROS1 node. But we can also declare in ROS2 this Lifecycle node. Okay? In this class, in this open class, we are going to be focusing on this special type of node, which is the Lifecycle node. Okay? Then, first of all, why do we need managed nodes? Well, managed nodes are very useful. Before we get into explaining what they are, and we get to see a little bit more in depth what these lifecycle managed nodes are, Why are they useful? Well, they can be very useful, for instance, in systems where we are launching and we have to coordinate and cooperate between several nodes. For instance, a navigation system. Yeah, this is very useful, for instance, for nav2 in this case, which is a navigation system for ROS2 robots. Then, in order to have a nav2, a navigation system working, we have to coordinate several nodes, like a mapping node, a localization node, a path planning node, the recovery behaviors, etc., etc. So we have to coordinate several nodes. Then, in cases like this, it's very useful to be able to manage a node, to manage the different states that a node is going to be going through. Okay, we are going to understand a little bit better this in a moment when we get a little bit more in depth in what these lifecycle nodes are. And also this is very useful. For instance, there are many more cases. Okay, here we are just putting a couple of them. But lifecycle nodes, for instance, allow us to restart or pause nodes. Yeah, so we can tell a node to move into a paused state. All right, or we can also command a node to restart. And this is useful, for instance, in case that we want to change some parameters of that node. Yeah, as you know, in ROS2, parameters are very related to each node. Yeah, this is an important difference from ROS1, where we had the ROS core and the ROS parameter server, which managed parameters, and they could be accessed by different nodes and so on. In ROS2, parameters are associated to a node. Okay. Then, for instance, using these managed nodes, these lifecycle nodes, we can manage the state of a node. We can tell a node to restart, change some parameters, and then start again. Yeah? Okay. This might be, and in fact, it is a little bit abstract. So let's try to get a better idea of how these managed nodes work. So, basically, managed nodes can have different states. Yeah, so you can understand that a managed node is a node with different possible states. Okay, so if you run a normal node, you are going to start it, and it's going to be working until you stop it, for instance, with a Control-C or whatever. Right? In a managed node, this node can be in different states, and you can control, you have indeed control on which state you want your node to be. Yeah? And depending on in which state your node is, it is going to do some things or another's. Yeah? Then the possible states of a managed node are the following: unconfigured, inactive, active, and finalized. Okay? Then, first of all, when we start a node, it's going to always start in the unconfigured state. All right? Then, in case we want to, start it, let's actually have a look at this image, because it's more graphical, and it's going to give us a better idea of the different states and how to move from one to another. Okay, so this is a diagram, let's say, of the different states and how they interact between each other. Yeah, these are a diagram of the different states that a managed node, a lifecycle node, can have. So first of all, when we start the node, it's going to be in an unconfigured state. Okay? Then the next state that we can move the node to is to inactive. Okay? And we can pass, let's say, the node from unconfigured state to inactive state through this unconfigure function. Okay? In a moment, we are going to see an example where we are going to see all these functions, how they are defined, and so on. But for now, let's get an idea of the different states, which are unconfigured, inactive, active, and finalized. All right? These are the main, the four states that a managed node can be in. Then, for instance, if we want to move our node from unconfigured state to inactive state, we are going to do this through the onConfigure function. Okay? If we want to move our node from inactive state to active state, we are going to do this through the onActivate function. And on the other side, if we want to move our node from active to inactive state, we are going to do it through the onDeactivate function. Okay? Then we can also move the node from inactive state to unconfigured state through the onCleanup function, and from inactive to finalized through the onShutdown function. Okay? Then, for instance, we can also move the node from unconfigured to finalized directly through the onShutdown function, for instance. Okay, we can also move the node from inactive state to finalized through the onShutdown function. Yeah, you get the idea from this diagram, more or less, of what are the different states of a managed node and how they interact with each other. Yeah. So from this open class, I want to make clear that the goal of this open class is not to have you understand 100% how these managed nodes work. Okay, it's just to grasp a general idea. Okay. In fact, this is a feature that it's still in development. So ROS2 developers, ROS2 communities is still working on this, on developing this. For instance, this is a feature that it's currently only available in C++. Yeah, there is no Python API in order to manage these lifecycle nodes, for instance. So this is something that I'm sure that in the future is going to be done. But so this is just to show you that this is a feature that it's still in development. Okay. Yeah. So far so good. Let me know. Are you following? Any question? Are you already lost? You don't understand anything of what I have been explaining? Yeah, so here we have this node, which I was just commenting, that at present, managed nodes are only available for C++, not for Python, okay? Good so far, says Ryan. Okay. Everything can be followed so far, says Zoltan. Okay, great. Then let's keep moving. All right. So let's see an example then. As I have just said, the code is going to be in C++, okay? Because managed nodes, lifecycle nodes are not available yet for Python, okay? So we are going to have to be working in C++, all right? Then here we have the code for creating a quite simple managed node. Then for now, let's just skip on the code. We are going to review it later, okay? So far, what we are going to do is to just create a package, create this C++ script, compile it, and run it, okay? And once we have this running, from there we are going to be seeing in more detail what are all the different parts of the code, okay? So let's get to work then. So let's start by creating a new package, okay? We are going to create a new package. Then for this, we are going to come back to the shell, and we are going to click in this plus button that we have here, which is going to open a new shell here. There we go. All right. Then we are going to come to the ROS2 workspace src folder. Okay. Then once we are here in the ROS2 workspace, we are going to run this command that we have here, right here. Okay. ROS2 package create, manage the scan, etc. So I'm going to copy directly here from the notebook and paste it here to the shell. And as you can see, basically here we are creating a new package named managed scan. It's going to be a CMake package. And I am adding some dependencies to this package like RCL CPP, lifecycle messages, or RCL CPP lifecycle. Yeah, these are the dependencies that I am adding. So I'm going to run this command, and this is going to create my new package. Okay. Then now, in order to better work with packages, folders, and so on, I'm going to open the graphical environment, the code editor, basically, which is going to allow me to better deal with code and so on. So you can open the code editor by clicking on this second button here, which says Code Editor. So I'm going to click on here. This is going to open the IDE. Sorry. There we go. As you can see here, you have access to all the different workspaces that are inside this project. In this case, we are going to focus on the ROS2 workspace, because here is where we have created our new package. So if we open the ROS2 workspace and the SRC folder, we are going to see our package, which has been created right here, managed scan. All right. Then inside this package, inside the SRC folder, we are going to create our C++ script. Okay? So let me go back here to instructions. So we are going to create this script named managed_scan.cpp. So let me create it like this. New file, managed_scan.cpp. Now inside this script, I'm going to paste all the code that I have here. So let's copy all the code that we have here in the notebook and paste it here into my file. All right, there we go. So I have created my package. I have created a CPP script inside my package. You are going to see that here it shows like it has some errors, but don't worry, okay? Well, actually there is an error now that I am seeing the code. So it is indicating one error here, and it is true that there is an error, okay? As you can see here, we have to close this line, right? Like this. Okay, so make sure that you fix this line, okay? I thought this was already fixed, but apparently not. Okay. Yeah, have you localized this error? It's in line 100. Okay, you have to close here the line like this. Yeah. And yeah, have you fixed this error in your script? Line 100, okay? Very important. If you don't fix this, now when we compile the code, it's going to crash. It's going to give us error, okay? Yes, it has been fixed. All right, very well. Then let's keep moving. So, yep. Then next step is going to be to compile our code, okay? So for this, we are going to have to add some lines to the cmakelists.txt file of our package, okay? So I'm going to grab this code snippet from here, okay? It's right below this ROS2 package create command. So I'm going to get all this code here, and I'm going to paste it into the cmakelists.txt file. So I'm going to open this one, and here at the bottom, here, I'm going to paste this code. Okay, what I am doing here, very simple. I'm just creating an executable, which is going to be named scan publisher. I'm generating this executable from the script that I have just created. Yeah, this managed scan.cpp. So I create my executable. I define the dependencies of my executable, and then I install it. Okay. Then, all right, then I'm going to do one extra thing, which is to create a launch file for my node. Okay? Then, for this, I'm going to come back here to my package, and I'm going to create a new folder. Okay? I'm going to right-click here in Managed Scan, New Folder, and I'm going to create a new folder named Launch. All right? Then inside here, I'm going to create a new file. Inside the launch folder, I'm going to create a new file, which I'm going to name managed scan.launch.py. Okay? Remember that in ROS2, launch files are Python scripts. Okay? So I create my new launch file. Okay? There we go. And then I'm going to paste here the contents of this launch file, which is this. So I'm going to copy the contents from the notebook and paste them here. There we go. Okay, so as you can see, this is very simple. We are just, the interesting thing here is that, as you can see, we need to return a lifecycle node object. Yeah, not a regular node, but a lifecycle node, which we are importing right here. Yeah, this is the important thing here. For the rest, we just indicate the package, the executable we want to run. Then we define here a name for the node, and we set the output to the screen. Okay, nothing special here, but pay special attention here that we are using the lifecycle node object instead of the regular node object. Okay? All right. Then final thing that we have to do is to add these lines to the CMake list again, okay? So just copy them directly here from the notebook. Let's go back to our cmakelist.txt file, and here, down here, we are going to paste this line, okay? So here, what we are doing is to just install the launch folder with the launch file inside, so that now when we compile, the ROS2 system can find this launch file. Okay? All right, so yeah, at this point, we are ready for compilation, so let's go for it. Then for compiling, remember that you have to be in the root of the workspace, so here, in the ROS2 workspace folder, not in SRC. Yeah, you have to be in the root of the workspace, and then here we can run the command call combuild in order to compile the workspace. This is going to start compiling and generating the executables and so on. It's going to take some seconds, and if everything goes okay, let's see. If you have done some of these steps wrong, you are going to get an error here, okay? But if we have done all the steps properly, this should compile correctly. So let's see how it goes. There we go. So one package finished, no errors. So everything has compiled properly, apparently. Then, very important, once you finish compiling, you have to source. I am hearing myself here. 1 second. Okay. Yeah, so let's source our workspace. I'm hearing myself. All right, there we go. All right. Okay, and now we are ready to launch our code. So ROS2 launch managed scan, and then the launch file, which is managed scan.launch.py. Right? So let's execute this. And there we go. So we have right now our managed node, our lifecycle node running. Okay? Yeah, so far so good. Have you all followed the steps? Create the package, create the script, create the launch file, and compile everything, and then finally run the script. Are you following? Okay, I don't see any messages, so I suppose that everything is going all right. Otherwise, probably you would be writing here in the chat. So I'm going to suppose that everything is working correctly. All right. Then, okay, so we have in one shell our simulation running. Okay, don't forget about this. We have our gazebo simulation running here. And we have our lifecycle node running here. Okay, okay. Now David says, okay, it is running. Great. Then, what is happening here? So right now, at this point, let me make you all a question. At this point, in which state you think the node is? Let's go back here to the diagram. In which state the node is right now? Can somebody tell me? Unconfigured, says Ryan, but you don't look very sure about your answer, Ryan. Yes, you are right. You are right. It's unconfigured. Okay. So right now our node is in the unconfigured state. Okay. So let's have a look at some things. Okay. Now that we have it running, we can run a ROS2 topic list, for instance. Let's open a new shell, okay? I'm going to leave my node running here, and I'm going to open a third shell here. And then I can type here, for instance, ROS2 topic list. This is going to show me a list with all the topics, okay? And I'm going to see this topic here, which is managed scanned node transition event, okay? Basically, this topic is the one that has been added right now by our managed node. Yeah, managed scan node transition event. So this topic, as you can see, it's automatically created by any managed node. Yeah, so always that you create a managed node and you start it, you are going to get this topic here. And what is this topic for? Well, basically this topic is going to monitor the different transitions of your node from one state to another. Yeah. Then, so we can, for instance, yeah, so we can have a look here at this topic. We can subscribe, create an echo. You have the command right here, ROS2 topic echo managed scan node transition event. So we are going to listen here to this topic, and as you can see right now we have no messages being published here. Okay, so this topic is going to get a message whenever I change the state of my lifecycle node. So far I have not changed the state of my node, so I'm not getting any message here. Yeah, makes sense? All right, then second thing that we can see is that there is no top. Well, first of all, leave this command running here, okay? So we are going to have the current setup is that we have in the first shell the gazebo simulation running, yeah? In the second shell we have our managed node running, and in the third one we are going to leave this ROS2 topic echo, which is subscribed to this topic, listening to this topic for any message that is published. Okay, we're going to leave here. We are going to leave this command running here, and then we are going to move to a new shell. All right. So one thing that we can see is that there is no topic named managed scan. Okay. So let's have a first look here to our code. And if we have a look here to our code, we are going to see that, let me look for it. Yeah, so here we have a publisher, right? We are creating a publisher which should be publishing to the managed scan topic, right? This is a publisher which is expected to publish messages into a topic named managed scan, right? However, if we do a ROS2 topic list, this topic is nowhere, so we cannot see this managed scan topic, right? We can see this managed scan node transition event, but not this one, okay? Then can somebody already at this point tell me why we can see this topic? This is a difficult question, okay? But let's see if somebody has an idea of why we cannot see this topic. Does somebody have an approximate idea of what could be happening? Okay, this question is maybe a little bit harder, at least at this point. Okay, so you have the answer here. All right, don't panic. We are going to you have the answer here. So we are not seeing this topic because the node is still unconfigured. Very well, Francois. So Francois has gone for the answer, and he is right. Okay. So the problem is that the node is still, our node is in the unconfigured state. Yeah, it's still in the unconfigured state. This is why I cannot see yet the topic. Then, if I want to see the topic, what should I do? Well, I should move my node from the unconfigured state to the inactive state, at least, right? Then let's do that. Let's move our node and change its state. So here you have the code, okay? Then as you can see in this snippet, okay, this subscriber is created in this function onConfigure, okay? Inside this onConfigure function is where we are going to create our publisher. We are also going to create a timer, as you can see here. But we are going to create our publisher in the onConfigure function. So, if we come back here to our diagram, we can see that when we move from the unconfigured state to the inactive state, we are calling this onConfigure function. Right? Then in this onConfigure function is where we are creating the publisher. Okay? Then if I move my node from the unconfigured state to the inactive state, I'm going to trigger this onConfigure function, and therefore I'm going to trigger my onConfigure function, and therefore I am going to create the publisher. Yep, makes sense? Then let's go for it. So let's go for it. Let's go down here. Okay, yeah, another important thing to note, okay, so we have the code here for the onConfigure function. You can check the code here. Then an important thing to know is that whenever we create a publisher in a lifecycle node, this is not going to be a regular publisher, okay? It has to be a lifecycle publisher. This is a special type of publisher, okay? If this is, you can see here the definition, yeah? So it's a lifecycle publisher, Yeah, it's not a regular publisher, a publisher that you would use in any regular ROS2 program. Okay, in this case, you have to use a special type, which is this lifecycle publisher. Okay, why? Because this object has some functions like activate, reset, has some special functions that are going to allow us to restart, for instance, a publisher, to activate a publisher, and so on. Okay, we are going to see some of these functions later, but take into account this. Okay, when you create a publisher in a lifecycle node, it has to be a lifecycle publisher. Okay, then another thing worth mentioning is that this is not yet available for subscribers. Okay, so we only have this lifecycle publisher object for publishers. For subscriber, this object is not yet available. Okay, as I've said before, this is still being developed, so it's still in a development stage. Then there are some things that are yet not developed. Okay, then just keep in mind this. Okay, this is special type. It's only available for publishers. Yeah, this lifecycle publisher. We don't have yet a lifecycle subscriber. All right. Okay. Then, okay, so we have already answered this question, in fact. Yeah, we are a very smart class, and we already did answer this question. In any case, in case you don't want to be thinking too much, and maybe you are moving your node from one state to another, and at some point you don't know in which state is currently your node. So you have this command, ROS2 lifecycle get, and the name of your node, which is going to tell you in which state is the node. So let's run this command here, and let's see in which state our node is currently, and it's in the unconfigured state. Okay, very well. So we said that it was in this state, and we were right. Okay. Then we can change the state of the node by running this command. Okay, ROS2 lifecycle set managed scan node and configure. Okay, this is going to trigger the onConfigure function. Yeah, this is going to trigger the onConfigure function, and it's going to move. This is going to trigger the onConfigure function, and it's going to move our node from the unconfigured state to the inactive state. Okay, we can do this with this command that we had right here. We have it right here. Okay, let me copy it from the notebook and run it here. ROS2 lifecycle set the name of the node and configure. Okay, let me make this a little bit like this. All right, then let me run this command. Okay, so it says transitioning successful. Okay, so now if I get the state of my node, what are we going to get? Now it is in the inactive state. Okay, so we have successfully transitioned our node from the unconfigured state to the inactive state. Also, if we check this shell that we have here, we are going to see a new transition event here. Yeah, we have moved from unconfigured to inactive state. Okay? All right, very well. So far, so good. Yeah, does this make sense? Are you following the class? Yes, no? Yes. Okay. Very well, Zoltan. All right. Then, yeah, it is worth mentioning also that we have this command, ROS2 lifecycle list managed scan node -a. So what does this command? Let's run this command and let's have a look, because it can be very useful for some situations. So this is going to print basically the wall diagram of states of our node. Yeah. So state number 1 is configure, as we can see here. And then there are 3 possible transitions from the configure, from the unconfigure state. Yes, we have 3 possible transitions. Transition success. So if everything goes okay, we are going to move from from the unconfigured state to the inactive state. Right? Sorry. If the transition fails, then the goal is going to be unconfigured. Yeah, so we are going to start on unconfigured state and we are going to remain on unconfigured state. In case the transition results in an error, then we are going to go to the error processing state. Okay? We have, so this configure is going to move from unconfigured to inactive. We have also the cleanup transition, okay, which is going to move our node from inactive to unconfigured. We have the right here activate transition, which is going to move our node from inactive state to active state, and so on. Okay, we have the deactivate transition, which is going to move our node from active state to inactive state, and finally we have the shutdown transition right here, which is going to move from unconfigured or inactive or active to finalized. Yeah? So here we have all the possible transitions and states of our node. Okay, so this can be useful for debugging and so on, this command. All right, then, all right, let's keep going forward. Then, okay, so now, remember, now our node is in an inactive state. So what happens now if I run a ROS2 topic list command? What happens is that now I can see the managed scan topic. Yeah? Makes sense? So now I can see this topic. Why? Because I have triggered the unconfigure function from my code. I have triggered this function, and then I have created the publisher. Okay? But what happens if I try to read the messages from this topic? Let's run here a ROS2 topic echo managed scan. What happens if I try to get the messages from this topic? It happens that there are no messages being published into the topic. Okay? Why there are no messages being published into the topic? Someone tell me. Now this one you should know it. So I have the topic available, but there are no messages being published into the topic. Why there are no messages? Because it's inactive. Very well, Logan. Because it's inactive. My node is in the inactive state, right? So I have moved from the unconfigured state to the inactive state. And in the way, I have triggered the unconfigured function, which has created my publisher. However, if I want my node to start publishing into the topic, I need to move it from the inactive state to the active state. Okay? And how I'm going to do this? Through the onActivate function. Yeah? In order to move from the inactive state to the active state, I'm going to trigger this onActivate function. And if we have a look at our code here, we are going to find the onActivate function right here. And as you can see, in this onActivate function, we are calling a special function of the publisher object, which is onActivate. Okay? This function, onActivate, it's a special function which is available in these lifecycle publisher elements. Okay, this is why we need to create these special elements. Yeah, we need to create this lifecycle publisher because these objects provide this function onActivate. Okay, so in the onActivate function, I am calling the onActivate function of the publisher, of my lifecycle publisher object. Okay, then this function is going to activate the publisher element, and it's going to start publishing messages. Okay. All right, then let's try it. Let's see what happens. So let me go back to the notebook where we were down here. Okay, so now we are going to activate our node. Okay, so ROS2 lifecycle set, name of our node, and this time we are going to activate it. Okay, so we are going to move it from an inactive state to an active state. So let me run this command. Hopefully everything is going to go okay. Okay, transitioning successful. So now, if we check the state of our node, let's check it again. What is going to say? It's in the active state. Very well. And now, if I echo into the managed scan topic, I can actually see the data being published. All right, perfect. Okay, so we have moved our node from unconfigured to inactive, which has triggered the unconfigured function defining the publisher, and now we have moved our node from inactive to active state, which has triggered the onActivate function, and therefore it has started publishing into the topic. Okay, so now what could we do? For instance, now we could go back to inactive. We could shoot down. We could shoot down our node and set it to the finalized state, right? So let's have a look at the following steps here in the notebook. Okay, yeah, so here we have activated our node, which triggers the onActivate function. Yes, which is going to make our lifecycle publisher element call the onActivate function. Okay. So don't mix this onActivate function with this one. Okay. This onActivate function, it's defined in our code. We can see it here. Yeah, this onActivate function, we can see it here. This onActivate function is a function defined in the lifecycle publisher element. Okay, so we are not seeing it here. But basically, what this function does is to activate the publisher in order to allow the publisher to start publishing messages. Okay. All right, so yeah, so now we can shoot down our node like this. Very simple. So let me do it right now. We can move finally our node to the shoot down state. So if I do this, let's run it right now. Transition successful. So now if I get the state, it's in the finalized state. All right? My echoing of the active node is not working, says Ryan. Never mind. Okay. So you figured it out, Ryan, by yourself? I was echoing the wrong topic. Okay, no worries, no worries. All right, then yeah. So when we shut down our node, then we are triggering the onShutdown function, which, as you can see, it's calling the reset function from both the timer and the publisher. Okay, so at this point, if we echo our topic, of course, it's not there. Yeah. If we do a ROS2 topic list, we are not going to even see it there, neither. Okay? All right, then, yeah. So we have an extra function, which is this on the activate, where we have a couple of them, actually. We have a couple of extra functions, which are, let's have a look here, which we have seen the onConfigure, onActivate, and onShutdown, okay? We have the onDeactivate function also, which is the one triggered when we we change our node from active to inactive. Then basically, what this is going to do, we can check the code here. onDeactivate. Yeah, so basically what this does is to call the onDeactivate function from the Lifecycle publisher. So basically what's going to happen here is that it's going to stop the publisher from publishing messages, but it's not going to close the topic, okay? So the topic is going to be there, but it's not going to be publishing messages anymore because it's going to be in the inactive state, okay? And we have also the other state, which is on cleanup. Okay, on cleanup is going to be triggered when we move our node from an inactive state to an unconfigured state. So basically, it's going to do, in this case, the same as the shutdown. Okay, it's going to reset the topics. Yeah, so we can see it here also on cleanup. Yeah, so it's also calling the reset function for the publisher and the timer objects. All right. And we have here also the onError, of course, just in case something goes wrong. In this case, we are not doing anything, just printing an error. Okay? So, sorry. Yeah, so there's one last thing that I would like to comment, okay? We are low on time, but let's just comment this. So, so yeah, we can pause a node. When we have it running, we can pause a node by moving it from the active to the inactive state, right? So if we move our node from the active to the inactive state, this is going to be equivalent as pausing our node, okay? Because we are not going to be closing the topics, but we are going to make them stop publishing. So this is similar as pausing the node. Yeah, is to move our node from active to inactive, which is going to trigger the onDeactivate function. And then finally, there is the option, the approach also to restart a node. Yeah, which means deactivating and reactivating. So in order to do this restart process of a node, we have to first bring it to the inactive state. Yeah, so basically it's going to go all the way back. Okay, so let's say that we have our node in the active state, so it's working properly. Then if we want to restart it, we are going to have to go first back to the inactive state, and we are going to have to go back again to the unconfigured state through the onCleanup function. And then here maybe we can change some configuration things related to our node, and then we can restart it again and set it back to the inactive and back to the active state. So this whole process of going back to unconfigured and back to active is the equivalent to restarting the node. Okay? Yeah? And for instance, you cannot go from active to unconfigured directly. Okay? That's not possible. If you want to go to unconfigured, you have to first go to inactive and then go to unconfigured. In the same way that it's not possible to go directly from unconfigured to active. Okay? You have to first go to the inactive state and then you can go to the active state. Yeah? Do you get all this idea of the different states and transitioning from one or another? Does it make sense? Yes? No? Excellent, says Logan. Thank you. Thank you, Logan. All right, so yeah, basically we are there. Francois asks use case. Well, there are many, especially as I mentioned it here at the beginning of the class. This is very useful for systems, okay? For systems where you are going to have to coordinate and work with several nodes, okay? Example, a very simple example is navigation, okay? So lifecycle nodes are used in navigation because in nav2, in navigation 2, of course. This is used, why? Because you have to coordinate several different nodes. You have the map server node, you have the AMCL localization node, you have the planner, the path planner node, the controller node, the behaviors node. You have several nodes and you have to coordinate them. For instance, you cannot run the localization node without having already the map server node running and providing a map, okay? And in order to control all these nodes and having the option to control the states, this is something very useful for navigation, for instance. Yeah, and you can, for instance, you can restart a node in case that you want to change some parameters for a specific node. You can restart it. You can bring it to the unconfigured state, change some parameters, and then bring it back to the active state. So the most common use case and the most known one, the most popular one probably is for navigation. Okay, this is very used in navigation. In fact, before finishing with this open class, I wanted to let you all know we are going to be doing a navigation 2 training. Okay, in April 25th, so at the end of the next month, we are going to be doing a intensive training, a very intensive training on ROS2 navigation, where we are going to cover this topic, Lifecycle Manager, along many other. Okay, so we are going to be seeing SLAM in ROS2, path planning with obstacle avoidance, behavior trees for navigation, how to create controllers for path planning, etc., etc. Okay, so I left you here a link to the webpage of this training, and you have here all the details. So yeah, have a look in case you are interested, because we are going to be covering this topic, specifically lifecycle nodes and many other. Okay, so mastering ROS2 navigation training. All right, is one of the reasons for changing node state to reduce resource utilization? Yeah, that could be one. For sure, Ryan, yes. So instead of having one node publishing there forever without any reason, then you can pause it and only have it publishing when it is needed, for instance. Yes, exactly, Ryan. Yeah, so that's a very valid use case also. So you can send your node, your publishers to a pause state if you don't need it to be publishing. All right. All right, yeah, so let's leave it here. It's been already more than an hour, and we have managed to complete the whole notebook. So, yeah, that's all for today. Thanks to all of you for being here with me and sharing this open class. I hope that you have enjoyed it, but I hope that you have learned So something that would be great. And yeah, I'm going to see you all next Tuesday with the next open class. And until then, as always, keep pushing your ROS learning. Bye bye.